Introduction, PBL or Project Based on Learning is intended to assist students in using practical application, critical thinking and real-world problem solving. It motivates learners to engage more deeply with the information they encounter, improve the quality of their learning. Students can work according to their individual learning preference and communicate with their professor and peers in variety ways. There are 5 objectives that we gain from this project. Firstly is enhancing critical thinking ability. Secondly, develop the self-distract study skill. Thirdly, focus on depth of information attained. Fourthly, development of conceptual skill. Fifth, improve the teamwork.
From given data set, there are data of 3 parameters by 3 different operators. We reorganized the data by separating the data for each parameter as in figure 2. We found out there are missing data and decided to key in the mean of values from each operator into the missing spots as in figure 3.
Firstly, we used RStudio to plot the linear regression graph for length versus width based on the dataset. The plotted graph is shown on the slide. Using RStudio, we also managed to determine the residuals, coefficients, and significant codes of the dataset. Furthermore, we also determined the residual standard error, f-statistic, and p-value of the length versus width regression graph. As shown in the slide, the coefficients for the length versus width linear regression are positive. This shows that there is a relationship between the two parameters, length and width. We then proceeded to plot the normality graph for length versus width of the dataset, which are the sample values versus theoretical values. This is the plot we obtained from RStudio. For the last graph using the parameters length versus width, we plotted the residuals versus fitted values graph using RStudio. This graph shows the outliers of the parameters length versus width.
For length versus height, we first plot a linear regression graph using RStudio. It can be seen that the line is a straight line, which tells us that this is a linear graph. The p-value obtained is 0.114, which is greater than 0.05. Next, we plotted the normality graph. From the graph, we can see that the line is mostly straight, which shows an absence of normality in the errors. Therefore, this is a normal distribution. The p-value obtained is 0.7481, which is greater than 0.05. Lastly, we plotted the residual graph, which shows residuals versus fitted values to obtain the outliers. Once again, we can see the graph is linear, and the p-value is 0.114.
As we can see, for the width versus height relationship, the linearity graph was plotted using RStudio. The summary shows the residuals of the graph: mean, first quartile, median, third quartile, and max. The coefficients of the graph are the intercept and height slope. The f value is 0.9562, meanwhile the p value is 0.3312. The regression line, or also known as the best fit line, is drawn with the help of least square method. Alpha value is 0.05, hence when the p value is less than the alpha value 0.05, it shows that the overall model is significant, but in this case, the p-value is more than 0.05, so it is not significant. To test the normality of the data, we have used visual inspection, which is the QQ plot, and also significant test, which is the Shapiro-Wilk normality test, which shows that the p-value is equivalent to 0.3505. P-value is more than alpha equals to 0.05, which implements that the data is normally distributed. To detect outliers, we have plotted the outlier graph where the y equals to 0, hence there is no linear relationship.
For quality control chart, we calculated the control limits of each parameter using Excel. For parameter height, quality control chart is in control because the graph lines lies between its upper control limit and lower control limit as shown in the slide. However, for parameter length, sample 17 is above the upper control limit, thus we conclude that X-bar chart from R and from S are out of control. This means that there might be anomalies in the dataset of the part's length. Quality control chart for width shows that there are 4 points that is outside of its upper control limit and lower control limit. Thus, the X-bar chart from R and from S are out of control and there are faulties in the dataset of width. This problem needs to be solved by the company in order to avoid any defects in their production process.
The result and recommendation throughout the project, RStudio proved to be powerful tool and statistical analysis offering a wide range of package and function. The analysis involved the examination of simple linear regression model, exploring the relationship between variables such as length, height, and width. The group gained hand-on experience applying statistical concepts and tools. They are demonstrating understanding the importance of linearity, normally, and control chart in data analysis. From now on, it's recommended that the company can consult the professional to get some tips. Next, they also can make mission checkup and service regularly. Lastly, conclusion. In conclusion, the Pbl project serves a valuable learning experience, showcasing the practical application of statistical analysis tools and fostering important skills in the field of mechanical engineering and manufacturing. Thank you.